Our learning goal today is to be able to solve using elimination when there is no common coefficient given. Okay, so you guys know in order to eliminate a variable, you've got to have the same number in front, opposite signs. Well, today I'm gonna give you some systems now that we've got to create that situation. So what it would be successful today you would be able to explain the steps to eliminate when you have to make the same common coefficient and know that elimination finds solutions to systems. So that's our ultimate goal, is to find the solution, okay? If there is no common coefficients in the equation, so you're going to be working with two equations, you will have to multiply one or both equations by some number. So you're going to have to be smart about what you're doing here to create matching coefficients and opposite signs. And then once we do that, then we can go ahead and add them together and eliminate a variable and go through the same steps as we did yesterday, okay? So that's kind of where we're at today. We're going to start with an example after you're done writing the steps. That's really what we're doing here. We're adding an extra step to elimination today, okay? So here is my example of a system where, can someone tell me which variable has the same coefficient? None of them do, okay? So the first thing I'm going to do is have you identify the 1 in front of the x. So the x's have different coefficients, the y's have different coefficients. So you have to now pick which variable you're going to make the same coefficient with. And I would be pretty smart about what I pick here because I don't want to work with bigger numbers. You want to target ones where they're smaller numbers and easier to manipulate. So I'm going to tell you that the best option here is the x's. So I want you to highlight your x's. This is the targeted variable that we're going to eliminate. And what I'm going to have to do is make sure that they both have a 2 in front and one has an opposite sign. So since I have to change the 1 to 2, I am going to multiply the first equation by 2, but then I'm going to make sure it's negative because I want opposite signs. Okay? So step 1 is making sure that they're lined up, which they're already lined up for us, and then we are manipulating the equation so that one of them has the same coefficient opposite signs. So step 1 then, I'm going to rewrite the first equation as negative 2x and make sure that when you multiply an equation by a number, every term has to be multiplied by that same number. So my y then is going to be negative 2 times 3, which becomes negative 6y. And negative 2 times 6 is a negative 12. Okay? And then we're going to make sure we rewrite the second equation exactly how it is because we're not changing that one. And now it's okay for me to go ahead and line this up because I have now created a situation where I can eliminate x. Okay, so when I go to add these together, now my x's zero out, which is what I wanted them to do. That was my targeted variable to eliminate. And then, of course, I've got to add everything else up. We're going to add these because they're same sign, so that's negative 13y equals, and this will be a negative 13. Okay, and then we go on to step 2, which means now we're solving for the remaining variable, which is y. So I'm going to divide by negative 13 on both sides here, and I have now y equals positive 1. And I'm now going to take that 1, that number for y, and use it to find x. So that means going back to an original equation, okay? I'm going to go to this one here. So this would be x plus 3 times y, which is 1, equals 6. So we're substituting in 1 for y. And I'm now going to solve for x. So this becomes x plus 3 equals 6. And to isolate x here, I'm going to subtract 3 over, and x now is going to be a positive 3. So this system ends up being one solution where they are touching at 3, 1. And if I wanted to illustrate, these are intersecting lines at one point. And we just used our second day elimination method. Okay? We're going to do several of these till I know that you're solid on it. We're going to talk about application again because tomorrow is going to be all about application with systems. Right? Second example. Okay? I don't have any that have a common variable, a coefficient. So I'm going to identify the 1 right there, and I'm going to manipulate the y's now. I know I can get rid of y if I make this y term negative 3. So I'm going to change all of this by multiplying it by negative 3. That's my targeted variable. I'm going to eliminate y. Okay? So that involves rewriting the systems after I manipulate the second equation. Okay, so this will become negative 6x, negative 3y equals negative 3 times 5 is a negative 15. And now I can go ahead and add them together and eliminate. So if I do that, now my y zero out, and I have 3x left on the left side. I have negative 3 on the right when I add them together. And then I'm going to divide by 3 here. So x ends up being negative 1. Now I'm going to use the number for negative 1 for x to find y. So I'm going to go back to this original equation here to find x. So that would be 2x plus, well, 2 times x, let's plug that in, 2 times negative 1, plus 1y equals 5. Okay, so all I did was take the negative 1, plug it in for x here, so we've got negative 2 plus y equals 5, and then to solve for y, I would add 2 over. So in this case, y is going to be 7. And again, I have a 1 solution. Negative 1, 7 will be the point that they share. Okay? All right. Next one. This is a negative 1y, targeting my y's. If I make negative 1, 4, negative 4, I can eliminate. So this time I'm manipulating the first equation by multiplying by 4. I don't have to make it negative. It's already negative for me. So I'm going to rewrite the first equation. 12x minus 4y equals 14 times 4, 56. And then the second equation is going to stay exactly how it is. And then we're going to add them together. So this will eliminate my y's. I've got 17x now equals 68. Divide by 17. And x is going to be 4. And then we're going to use 4 to find y. So I'm going to go to an original equation here. So 3 times 4 now. 3 times 4 minus 1y equals 14. And now we're solving for y. So 12 minus 1y equals 14. We're going to subtract the 12y or the 12 over. That zeroes out. I've got negative 1y equals 2. And then divide by negative 1. Do not ever ignore your negative 1s. They have to be divided out to isolate y. So this will be y equals negative 2. So again, one solution, 4 comma negative 2 is my solution to this system. All right, is there any questions so far? These are going to get a little more difficult on the back. Flip it over. Okay, let's skip this one, go to this one here. Okay, first of all, these are not lined up. So we're going to line them up first. Then we're going to start looking at which variable we want to eliminate. So I am going to add the 6y over, okay, to rewrite this in standard form. So if I add 6y, that's a plus 6y. So that's this one we rewritten as 3x plus 6y equals 12. Okay? And then I'm going to line up my first equation above it. And this is where I have to manipulate both of them, not just one. So my targeted variable here is going to be x because those are smaller numbers for me to work with. So I want to eliminate x. So what number do you think I have to have in front of those to eliminate x that I think I'm going to choose? You can make it any number, but we want to keep it small. So what? 6. We want to make it 6. So that means I have to multiply the top by 3 and the bottom by 2. Top by 3, bottom by 2. And then I have to make sure they're opposite signs.
I have a question.
Yeah.
If you multiply a 1.5 at the top one, wouldn't that be 3x plus 6y equals 9?
Okay, wait. Say it again.
If you multiply 1.5 on the top one, wouldn't that be no solution?
I'll have to see. Are you just trying to solve it without elimination?
Oh, yeah, kind of.
Okay. Well, let's see if you're right. Okay. So I'm going to choose to make one of those 6's a negative 6. So it doesn't matter which one. I'm going to go ahead and make this a negative 2 so that when I make it possible to eliminate, I want to make a negative 6 here. So I'm going to rewrite the first equation. 6x, okay, plus 12y equals 18. So I multiplied the whole equation by 3. And the bottom equation, I'm going to multiply by negative 2. So negative 2 times 3 is a negative 6x. Then I have a negative 12y. And I have a negative 24 here. Okay, so what I did is I manipulated both of the equations so I could eliminate a variable. Okay, so now when I go ahead and add these all together, I'm going to zero out the x term, which I planned on, but then it just so happens that my y's actually end up zeroing out. And now I've got 0 on the left side equals negative 6 on the right. And what does that mean about my solution? Yeah, so it's no solution, false statement. Okay. Did you have the same answer?
Yeah.
Okay. But remember, though, like, you've got to know the steps of elimination because on your EOC it could say, what's the third step in eliminating? Okay? All right. Let's go on to a couple of applications here using elimination where we're going to write the equations and then use elimination to solve. So these are always 2 items, similar but different. We label our x and our y, and then A goes with x, B goes with y, and C is the total amount. So it looks like Gabby and Sydney bought some pens and pencils. There's your 2 but different objects. Gabby bought 4 pens and 5 pencils for $6.71. So this equation is for Gabby. The second equation is going to be for Sydney. So for Gabby, she bought 4 pens. So we're going to let X represent the number of pens, and Y is going to represent the number of, or the money. This is the money for X and Y. Y is going to be the cost of pencils. X is going to be the cost for pens, okay? We don't know that. Money. X represents money. Y represents money. So for Gabby, she bought 4 pens. So A would be 4. It goes with the cost of a pen. B is going to be 5 because that goes with the cost of pencils, and the total amount that she spent was $6.71. Okay, that's Gabby's equation. So putting this all together, AX plus BY equals C. There's our first equation, and that represents Gabby. The second equation is for Sydney. So Sydney bought 5 pens, okay, so X again is the cost of pens, Y is the cost of pencils, okay, and then Sydney bought 5 pens, so 5 would be A, and 3 is going to be B in this equation, and the total for the second equation is $7.12. So now I'm going to put it all together. 5X plus 3Y equals $7.12. Okay, and now we're going to eliminate. I'm going to pick, you have to pick a variable to eliminate. So I'm going to pick X to eliminate. Okay, so I'm going to make them both 20 in front by multiplying the top by 5 and the bottom by 4. And then I'm going to make the top one a negative 20 by multiplying it by negative 5. So now we're rewriting both equations so we can eliminate. Negative 5 times 4 is negative 20x. Negative 5 times 5 is a negative 25y. And negative 5 times $6.71, $6.71 times 5 negative, is a negative 33.55. Okay, and then I'm going to manipulate the bottom. So 4 times 5 is 20x. 4 times 3 is a positive 12y. And then I'm multiplying $7.12 times 4, which is 28, 48. And now it's okay for me to add these together, and I'm going to eliminate X. Okay, so X gets eliminated, and now I'm calculating this. So 25 minus 12, because they're opposite signs, negative 13y equals, and then these are opposite signs as well, so $33.55 minus 48 is going to be a negative 5.07. And then to find y, we're going to divide by negative 13. So dividing by negative 13, that's going to give me y equals then a positive, which it should be because this is money, 39 cents. So y was the cost of pencils. Okay? So we know how much a pencil costs. So we're going to say pencils cost 39 cents. Okay? And now I've got to go find the cost of pens. So that's going to require that I plug in 0.39 in for y into the original equations. So I'm going to use the first equation. So we're going to solve for x now. So 4x plus 5 times 0.39 equals 6.71. Okay? So now I'm going to multiply 0.39 times 5. That's going to give me $1.95. And now I'm going to subtract it over. So we're going to subtract that $1.95 to both sides. So $6.71 minus $1.95. That's going to give me $4.76 left. And then we're going to divide by 4 to find the cost of pens. So pens are going to cost what? Pens are going to cost $1.19. $1.19. for pens. Okay? So we were able to solve this application by setting up a system and then solving it using elimination. Okay, we're going to do one more. Okay? So over here, at a sale on winter clothing, Cody bought 2 pairs of gloves and 4 hats for a total of $43. So for the first equation, the total is 43. Do we know the cost of gloves and do we know the cost of hats? So I'm going to pick which X is going to be. X is going to be the cost for gloves. Okay? Y is going to be the cost for hats. And I'm going to put this whole equation together. So it looks like Cody bought 2 gloves, so that would be 2X plus 4Y equals 43. Okay, and then it looks like Tori bought 2 pairs of gloves, so 2X, and 2 hats plus 2Y, and she spent $30. Okay, and then this one's a little easier to eliminate. Which variable are you going to eliminate here? X. What do I have to do to eliminate? Huh? 1's got to become -2. So I'm going to pick the top one, multiply by -1. So I'm going to rewrite the first equation. -2x minus 4y equals -43. And then I'm going to rewrite the second equation underneath. And then we're going to eliminate x. I'm left with -2y with y equals -13. And then divide by -2. So y is going to be $6.50 for y represented the cost of hats. So 1 hat costs $6.50, and then we're going to go find out what a glove cost. So we're going to go to an original equation. So I'm going to plug in 6.5 for y and solve for x. So 2x plus 4 times 6.5 equals 43. And then we're doing 2x. I got to multiply those numbers together. 6.5 times 4 is 26. And then we're solving for x. So we're going to subtract the 26 over. That becomes 17. Divide by 2. 17 divided by 2 is... So x is going to be $8.50. So it looks like the gloves cost $8.50 and the hats cost $6.50. Okay? And that's an introduction to tomorrow. Okay? So tomorrow, all we're going to do is solve application problems. Okay? I want you to take a minute over here. And I want you now we're at being smart about how we find solutions to systems. I've given you 3 systems, A, B, and C. You can only use one method of each, so you know 3 of them. You know how to graph, you know how to substitute, and you know how to eliminate. I want you to pick, looking at the system, which one you're going to use, what method, but you can only use it once. So you're going to have to graph once, you're going to have to eliminate once, and you have to substitute once. You're going to take a minute and start working on that independently. I want to see what options you're using. And then when we're done with that, you have a daily check-in to do, okay? So you have a few minutes here to work on this independently. Maybe talk to a friend or someone you're sitting by what method you would use and why, okay?
Can I borrow a calculator?